All right, good day everyone. So in this video, what I'd like to do is discuss something that I think quite often gets overlooked in tutorials of programming languages generally, and that is the concept of directories. So particularly in the context of modern operating systems, directories have sort of, I guess, like fallen into the background of basic computing knowledge that users are expected to have. You know, they're very much something that modern operating systems don't want their users to have to think or even necessarily know about. Now, to kind of illustrate what directories are and how they work, let's maybe do this first. On our desktop here, let's just create a file folder, and we'll call this folder Directory A. So we can just right click on our desktop here, select New, and select Folder. And as I say, we'll just name this Directory A. Then inside of this, we'll create another folder, and we'll call this one Directory B, like so. Then inside of that, we will create one more folder. We'll call this Directory C. All right, let's close that now. So maybe at the outset here, it's going to be helpful to get some terminology out of the way. So a directory is what most people refer to as a file folder on their computer, just like kind of what we've created here. But this is sort of a misnomer because the literal image of a folder that you see, on your desktop, for instance, is really just your operating system's way of visually representing what is more technically a directory. So a directory is nothing more than just a location or address, if you prefer, on your computer where files can be found. So in the same way, people have an address in the same way that people have an address indicating, where they live, files that are stored on your computer also have addresses. In other words, a directory is quite literally the address where a file lives on your computer. So let's maybe do this. Let's fire up RStudio here, and let's just create an empty script file and save it to our desktop. So we're just going to go File, New File, RScript, and we'll just go File, Save As, and put this on our desktop. So we'll call this our script, like so. Hit save, and now we'll close RStudio here. So you can see there is the script file that we just generated. Now, if we right-click on this file and select Properties, or if you're on a Mac, you would select something like Get Info, what you can see is we're actually given location information here. So the way you kind of read this location information is the C here indicates the drive that this file is located in. And within this C drive is the directory users. And then we have the subdirectory Belial. So when I say subdirectory, what I mean is that is just a directory inside another directory. And then within this subdirectory Belial, we of course have desktop, which is what we're seeing here. So altogether, this line here that we're looking at represents a path, really, to get to our script file here from the C drive. So that's the way you kind of interpret all of that. Now, interestingly, if we open up our script file here, and let's just minimize all of this. Let's get rid of that. So if you open up the script file, what you can see is right up here in the top corner of the console, in this bar just beneath the tab, you can see that exact same information listed out for us. So this address that we're looking at here it actually has a special name. It's what's called the working directory. And you can think of the working directory really as R's default directory. In other words, this is the default location where R is going to look for and save all of its files. So let's illustrate this with a simple example. What we're going to do here is we're going to create just a very basic data frame, and we're going to save this data frame to our computer as a spreadsheet file that we can we can open up. And we're going to do all of this, just using R code here. So in our script, we'll create a data frame and we'll just call it df for short. And we'll use the function data.frame here. And as I say, this will be a simple data frame. It's just going to have a single column of values. So we'll just call this column numbers. And we'll just say it's going to show us all of the numbers from 1 to 666. So we'll run that. And if we look, you can see we have just a data frame with 666 numbers. All right. Now, to save this data frame as a spreadsheet file, what we can do is we can actually use a function called write.csv. So write.csv. And what this function does is it takes a data frame and it generates a CSV file, which is just a universal type of spreadsheet file that any spreadsheet software can open. So to use this function, all we need to do is give it our data frame, and then we have to specify what we want our file name to be. So we're going to specify an argument called file, and we'll call this numbers_1.csv. Now this is technically all you need, but I'm going to actually add an additional argument to this because as is, if you just run the function, what it will do is it will save the row names of your data frame, which we don't usually want. So we'll just say row.names is equal to false, like so. And we'll run that, and you can see it gets sent to the console. So as I say, running this function will save a file on your computer called numbers_1.csv. But the question is, where has it saved this file? And as I said earlier, it has saved this file to the working directory, which in this case is, of course, just my desktop. And you can always, as a reminder, you can always kind of confirm what your working directory is just by looking up here. But in addition to that, we could also explicitly ask R to tell us what our working directory is. So there's a nifty little function called getWD. Whoops, but we got to do it in lowercase. GetWD. And this will literally just tell us what our working directory is. So if we run it, you can see it gives us the same information we have right there. And maybe what I'll do is I'll just write a little comment here. I'll say state the working directory. Okay. Now, actually, let's do this. So if we head over to our desktop, you can see right here we have numbers_1.csv. And if I open that up, it opens in my default spreadsheet software, which in this case is LibreOffice Calc. And there it is, single column of numbers, all the way from 1 to 666. Now, sometimes when you're creating files using lines of code, like we did with this write.csv function, it can be quite easy to lose track of what it is you're doing because basically, all of the important stuff is happening outside of your immediate line of sight. So something that can be helpful is a package called the FS package. So FS is short for file system, and it has a pretty nifty function called the directory tree function that will actually give us a visual representation of our subdirectories and all of the files contained within it. So what I think we should do is maybe install that package and kind of take a look at it. So why don't we do that here? So we'll say install.packages, like so. And as I say, it's called the FS package. So we'll run that, and then we'll use our library function to call it, like so. And now we can use the directory tree function. So the function is just dir_tree, like so. And this function is going to default to our working directory, which obviously is our desktop in this case, but you can actually set this function to use any location you want. And the way you do that is by specifying the path argument. And by default, the path argument is set to just a single period, which is just a shorthand way of referring to your current working directory. So anytime you see just a period, that's just referring to your working directory. So if we run this, you can see we get a nice visual representation of, our working directory here, all of the subdirectories it contains, and all of the files. So on my desktop here, we have a couple of files, right? We have the script file that we generated. We also have the spreadsheet file that we made. And we also have, 3 other folders that we created at the start of the video, and you can see that it shows they're nested within each other. So B is nested within A, and C is nested within B. And lastly, we have this other strange file called desktop.ini. And all this is it's just a hidden file created by Windows to keep track of changes that you've made to the desktop. It's not anything malicious, and it's probably best to just leave it alone. So if you see that, don't fret. It's nothing terrible. So we've saved a file into our working directory. That's the numbers_1.csv here. But what do you do if you want to save a file somewhere else? So for instance, on our desktop here, we have this directory A. So how would I save a file into that? Well, we actually have a few options here. So one option is to specify the complete file path when we're using this write.csv function. So what we could do is we could actually copy this. Well, no, let's type it out. So maybe we'll write a little note here. We'll say specify a complete file path to save in. So this is one option we have. So we're going to say write.csv, give it our data frame, say file, and now we're going to specify the entire file path. So we're going to give it, the drive, users, Belial, desktop, that sort of thing. Let's say c:/users/Belial/desktop. And then we're going to specify directory A. And lastly, we're going to give it the file name we want our spreadsheet file to be. So we'll call this numbers_2.csv, like so. And finally, we'll specify that argument that I mentioned earlier, row names. We'll set that to false. Oops. So we can now run that and move this over. And in fact, if we run the directory tree function, what we can see is within directory A, we have numbers2.csv. Now in this case, we specified the full file path, but we didn't actually need to do that. We could have saved ourselves a bit of typing. And the reason we could save ourselves a bit of typing is because directory A is just a subdirectory of our desktop. So we don't actually need to type the entire file path if something like that is the case. So let me kind of illustrate what I mean here. So what we could have done instead, let's give ourselves some space. All right, so what we could have done instead is we could have just specified a subdirectory specifically to save in. So we could have, we'll just write in a little note. We'll say specify a subdirectory to save in. So we could have typed write.csv, given the data frame, said file, and then here we would just say directory A, like so, and then type the file name. This would have been completely sufficient. So we said numbers_3.csv. Whoops, it's supposed to be .csv. Say row.names is of course false. So running that, if we take a look at our directory tree function now, you can see we have numbers3 located in directory A. And you can see we've typed considerably less. And the reason we're allowed to do that is just because directory A is a subdirectory of our working directory. Now, a third option to save in directory A here would have been to actually just change our working directory specifically. So what we could have done instead is something like this. We could say change working directory. So we could use the function setwd to change our working directory. And inside this function, we just give it the file path. So we could say c:/users/ Belial / desktop, and then give it the last directory A. So as soon as we run this, what you'll see is that will change. So you can see now it's changed, and we can then just save our CSV file kind of in a more conventional manner. So we could just say write.csv, give it the data frame, save file, and we're on numbers 4, I guess. Numbers4.csv, row.names, set that to false, like so. And now, if we run the directory tree function, keep doing that, directory tree, you can see there is numbers 4. And you can also see that because we've changed our working directory here, the directory tree function has also changed. So now what it's showing us is just directory A. We're not seeing any of the desktop. We can only see the files in directory A, directory B, and directory C. Now presently, our working directory is A here. But I think for illustration purposes, it's going to be helpful if we actually change it to C. Now, because directory C here is a subdirectory of A, we don't actually need to type the entire file path like we've done here. We can if we want, but it's not strictly necessary. So let's just quickly change this. So we're going to say setwd, and then we're going to say directory B, and then within that we have directory C, like so. So we'll run that, and now you can see that has correspondingly changed. And if we run the directory tree function, like so, you can see directory C is just completely empty. It has no folders or files in it, so consequently we don't have much to visualize here. Now it's worth asking at this point, what would you do if you wanted to save a file in directory B, but you don't want to change your current directory from what it is now, which in this case is C. So in other words, what would you do if you wanted to save a file kind of one directory up without changing your current working directory? Well, the way we can do that is just by using 2 little periods to indicate that we want to move up one directory. So in the same way, a single period indicates our current working directory. 2 periods indicates that you want to move up one directory. So let's maybe get ourselves some more space here. And we'll just write a little note. So we're going to be doing this. We're going to say saving in directory B from directory C. So we're going to say write.csv and give it the data frame, say file, and where we specify our file path here, we're just going to put 2 little periods like that, put a slash, and then type our file name. Numbers underscore, I think 5 is what we're on, .csv. So this just indicates that the 2 little periods here indicate that we don't want to save in directory C, we want to save in directory B. And say row.names is false. So run that, and now if we use our directory tree function, this function is going to default to our working directory, which you can see shows nothing. But if we want this to show kind of one directory above, what we can do is literally just add 2 periods like that. Run it, and now it shows us directory B. You can see within directory B we have numbers underscore 5. .csv. So that's how you move up one directory. If you wanted to move up two directories, the process is quite literally identical. So let's suppose, we're in directory C now. What if we wanted to save a file in directory A? How would we go about that? And as I say, it's exactly the same. So we'll say saving in directory A from directory C. So we're just going to say write.csv like so. Give it our data frame. We're going to say file. And we're going to say // numbers _6 .csv row.names is false, like so. Run that. And now say directory _tree. And we just move up. Whoops. We just move up two directories. Run that. You can see in directory A here, we have numbers6.csv. And then, in directory B, we have numbers5. And then in directory C, there's nothing whatsoever. And if we wanted to do something like change our working directory back to the desktop, what we could do is, of course, we could specify, a full file path, but that's kind of inconvenient. Alternatively, we could use this little dot method. So what we'll do is we'll say moving the working directory up 3 levels. So set working directory // and so before I run this, just take note of our current file path here in the working directory. We run that. You can see now we are back to the desktop. And in fact, if we run the directory tree function, you can see there is everything. So we can see our script file, we can see the very first spreadsheet file we created, and all of the others. And at this point, it's also worth knowing that you can pretty easily create your own directory just by using kind of a basic line of code. So let's do this. Let's create a D directory inside the C directory while still keeping our current working directory what it is, which is, of course, the desktop there. So we'll write a little note. We'll just say create a new directory D. So we're going to use the function dir.create. And then all we need to do is, specify a path argument. And because directory D is technically a subdirectory of our desktop, we don't actually need to use the full file path. So we can just say directory A / directory B / directory C / directory, let's spell that correctly, directory D, like so. Run that. And now we say directory tree. You can see A, B, C, and finally D. Now it's worth mentioning that file paths on your computer can get quite long and cumbersome to not only type, but also to look at. You can see here we didn't even type the full file path, and it's still kind of annoyingly long. So what most people will do is they'll quite often make use of a function called the paste function. So I'll kind of illustrate how this works. The paste function is a pretty basic function that you'll probably find yourself using quite a bit just in your travels with R. And all it does is it combines multiple strings together into one big string. So for instance, suppose we had a string and this string just said bread. And suppose we had another string and this string said spam. And suppose we had a third string that just said bread. If we run this function, it will just merge these three strings into one string. So you can see that's precisely what's happened there. And by default, the paste function actually puts a space between between each of the strings. But you can actually specify specifically how it. You can actually specify. What am I trying to say here?
I'm a dumbass.
You can specify the character that it uses to separate the strings. I mean, um, uh, so for instance, what we could do is we could specify an argument called sep, which is just short for separator, and we could put like 3 plus signs. And if we run that, you can see each string now is separated by 3 plus signs. So when it comes to file paths, what we can do is we can do something like this. We could first store our working directory as a string. So we could create an object like wd, for instance, and we'll just say get working directory. So if we run that and take a look, you can see that gives us our current working directory as a nice string there. Then what we could do is we could store all of our subdirectories as unique strings if we wanted. So we could do something like this. We could say directory A is just going to be directory A, directory underscore B will be, say, directory B, directory C is, of course, directory C, and lastly, directory D is just directory D. Just like so, we'll run all of those. And now what we can do is we can just paste them together as necessary, right? So if we wanted, a file path all the way to directory D, we could just use our paste function to create that. So we would say something like wd, and then we would say directory A, A, and we would say directory B, and we'd say directory C, and lastly we would say directory D, and then we would just tell it to separate with the /, like so. Run that, and you can see we get the entire file path to directory D. So if you wanted to, change your working directory, what you could do is you could store this as an object. So we could just say new, we'll say new working directory, like so. And then you could just use the set working directory function and input that object, like so. When you do that, you'll notice that has now changed. So our working directory is now set to D with arguably less typing, you know. Handling your directories in kind of this modular fashion, at the moment may not seem terribly efficient, but when you're doing kind of more complex instances of programming, this kind of thing can be quite handy. So that's directories in a nutshell. It was kind of a crash course, but hopefully that's kind of clarified things for a lot of people, because I know this is a topic that quite often doesn't get covered. So I thought I would make a video on it specifically. Anyway, I will talk to you guys in the next video. Thanks for watching.